In this video, I will show you how to analyze the data that you have collected for when the duct tape roll rolls down the inclined plane and falls onto the pillow below. So we have collected data for omega about the x, y, and z axes, and you will notice that the data for the rotation about the x and the z axes are actually consistent with 0, and we don't really require them, so we can remove those two data sets. We're merely interested in rotational velocity about the y axis. So that is this blue line. So you will notice that there are two portions to this data. There is a linearly increasing part and then a flat part. Thereafter, this is data when the duct tape roll fell onto the surface of the pillow below. So the first thing you want to do is select the magnification tool and zoom in on this portion of the data. And next you want to apply a smoothing filter to just smooth out the data a little bit. Now here we are interested in only the linearly increasing part. We are not interested in the projectile motion part of the lab. That we've already seen in lab number 4 earlier. So we are actually interested only in the linearly increasing part when the duct tape roll was rolling along the inclined plane. So notice that it starts off from 0 and then increases to some final angular velocity. The initial angular velocity is 0 because you let go of it when it was at rest. So it was subjected to some angular acceleration, and that is why this graph is more or less linear. So let us click on the analysis tool, and we are going to be interested in two things. So the first thing is to select this portion of the data from when you let it go till the point where you think it just fell off the surface of the inclined plane. So we're interested in firstly the slope of this data, and that can be seen here. You can see here that the slope is about 10.69 radians per second squared. So the slope is actually the angular acceleration. The second thing we're interested in is the final value of omega just before it fell off the incline. So that's this final value here, and the final value is 13.617 radians per second. So those are the two things that we are interested in, and we will employ that to determine the unknown quantities that we are required to find as part of the rotational dynamics lab.